Well, hey, everybody, this is Buzz Powell. I'm an associate director here at the National Center for Asphalt Technology. And hopefully you know that you're here to participate in a webinar on our long-term performance experience with a plant-based rejuvenator known as Delta S. We appreciate you being here, and we're going to go through this just as quickly as we can. And our hope and our intention is that this is going to provide some really useful value for you in your practice. So as we go through the content of this webinar, we're going to start out providing you with a little bit of background information on the National Center for Asphalt Technology. I'm going to introduce our presenters, and that's going to take you through an overview of the technology, a history of the technology in a sponsored test section here at the NCAT Pavement Test Track over 2 10 million ESL research cycles. Then we're going to go from there to a discussion of some implementation projects, give you an update on one of those projects, and then finally we'll end up with some question and answer there at the very end. So we've got a lot of content we want to cover in a pretty short period of time. So we're gonna keep on moving here, and hopefully Travis Walbeck, who's assisting us with this, he's our training coordinator here at the National Center for Asphalt Technology. So I hope that he is fixing to take control and show you guys our mission video here at the National Center for Asphalt Technology.
America relies on our highway infrastructure. For over 3 decades, our National Center for Asphalt Technology at Auburn University has focused on improving our roadways by evaluating and developing new technologies to make our roads smoother, quieter, safer, longer lasting, and more economical. NCAT was established through a partnership between Auburn University and the National Asphalt Pavement Association. We take pride in our strong relationships with state transportation departments, contractors, and others involved in the asphalt pavement industry. We strive to provide practical research results that are relevant and implementable into practice. Our highly qualified engineers understand pavement performance every step of the way, from the laboratory to the field. We are also developing the next generation of industry leaders. Students have the opportunity to obtain practical research experience, and many former NCAT Road Scholars are now in key infrastructure positions around the world. The NCAT Test Track is the only facility that combines real-world pavement construction with accelerated loading using heavy truck traffic. Highway agencies and industry sponsors fund research on the 1.7-mile oval, where our fleet applies over a decade of interstate-type traffic in only 2 years. Structural test sections have embedded strain and pressure sensors to measure pavement response to loads for validation of mechanistic empirical design procedures. Performance is monitored on a continuous basis to evaluate rutting, cracking, texture, friction, and noise. NCAT is at the forefront of pavement preservation research to quantify the life-extending benefits of various treatments and treatment combinations at test sections on and off the track. Our AASHTO accredited laboratory is well equipped to provide independent testing and analysis to help ensure that our roads are durable and keep drivers safe. People from around the world reach out to NCAT for assistance. We offer a wide range of hands-on training and can customize workshops to meet your specific needs. Asphalt is the most recycled material in America, and decades of research at NCAT have improved the sustainability of asphalt pavements. NCAT engineers are also using breakthrough materials and concepts to refine asphalt pavement designs, such as perpetual pavements and porous friction courses, which can enhance the quality of stormwater runoff while improving driving safety. Integrity is at the core of everything we do, and our research results are recognized worldwide as credible and objective. This gives our sponsors the confidence to move solutions into practice, saving highway agencies millions of dollars each year. Our mission at NCAT is to provide innovative, relevant, and implementable research, technology development, and education that advances safe, durable, and sustainable asphalt pavements.
There you go, Buzz.
All right. Well, thank you for sharing that video, Travis. As you saw there, kind of one of the big features here at the National Center for Asphalt Technology is the NCAT pavement test track. So it's one thing to have a world-class laboratory where you can characterize mixes and model performance, but the test track provides us with ground truth on how and pavement structures and preservation alternatives are actually going to perform in the real world. And you saw in the video, and you can see in this picture, we run a fleet of 5 heavy triple trailer trains. We call them heavy because the gross vehicle weight is about twice the legal limit, but we don't have bridge spans to collapse. So it's all about doing as much efficient pavement damage as we can safely do using legal loads. So every loaded axle on the track is loaded up to but not beyond the federal legal bridge limit. That's an important thing to mention here, because when you're talking about evaluating recycling agents, typically you've got higher wrap content in those mixes, and higher wrap content mixes can sometimes be strain sensitive, meaning when you load them heavy, you fail them faster, but you fail them in a way that is not necessarily going to be representative of performance under actual legal loads. So that's one of the things we do at the track that's really important to point out. The track operates in 3-year research cycles, where within each 3-year cycle, we compress 10 million equivalent single axle loadings into about 2 years of fleet operation, sort of sitting in the middle of those 3-year cycles. And the recycling agent that we're going to talk about today has been on the track now for 2 of those 3-year research cycles. So we've got a lot of lab data that we can share and a lot of track data that we can share. And then also that will carry forward to what we think is some really good implementation information for you. So just a word on the presenters. I was looking at some of the names, and obviously a lot of us know each other, but I'm Buzz Powell. I'm an associate director and a research professor here at the National Center for Asphalt Technology at Auburn University. But I started my career at Alabama DOT. I was there for 12 years. Then I was in the private sector for a few years, and now I've been here for 22 years, and associate director since 2020. So I'm going to handle some parts of the webinar today. Jason Nelson is another of our 3 presenters. He's been at NCAT for 17 years now, and he moved to the test track from the main NCAT laboratory back in 2011, and he's been our test track manager here since 2018. Jason and I work very closely here at the track, executing research and promoting and supporting implementation of findings. Our third speaker for today is Dr. Jay Bianchini. He was on the development team for Delta S and Delta Mist at the Warner Babcock Institute for Green Chemistry. He moved to Collaborative Aggregates in 2015, and he is currently the Chief Operating Officer. So hopefully, Jay, I got that information right on your bio to get you involved here in the webinar. So I am going to swap back to Travis, or at least stop screen sharing so that Travis can get Jay plugged into what we're doing here.
Good afternoon, everybody. My name is Jay Bianchini. I'm the Chief Operating Officer for Collaborative Aggregates, and one of the lead scientists that helped develop the Delta S and Delta Mist technologies. First off, I want to thank everybody for participating in this webinar today. And also, I intend to keep my introduction very brief as to allow the NCAT team a maximum amount of time to present their data. First, a little background on Collaborative Aggregates. Collaborative Aggregates spun off from the Warner Babcock Institute for Green Chemistry, where I was a research scientist for about 8 years. With the development of our Delta S technology, we decided to start a spin-off company. And the focus of Collaborative Aggregates is to bring to market construction and infrastructure materials and technologies developed at the Warner Babcock Institute that fall under the 12 principles of green chemistry. Our first product, our flagship product, and the focus of today's webinar is Delta S. Delta S was designed as an asphalt rejuvenator, and over the years, through third-party testing, we've determined it to be a very effective warm mix additive, compaction aid, anti-strip, and binder modifier. essentially what Delta S is a small molecule dispersion in a plant extracted oil. And what we did here as we formulated this material is we looked, one, for materials that came from renewable feedstocks, adhering to the 12 principles of green chemistry. And in identifying those materials, and as we developed the formulation, what we found was the oil we chose was very effective in dissolving our chemistry. It is also very effective and very fast at penetrating asphalt binder, whether it be liquid or recycled. And what it did was, as it penetrated the binder, it brought with it the chemistry that we put into that formulation. And Delta S, as it was developed, the purpose of what it was developed for was to soften asphalt for workability and paving, but then to set up for long-term performance of that asphalt without evaporation of solvents or separation of our material, oil, any of the formulation from the binder itself. And so what we've done over the years, in the past 6 years, starting in 2015, is participate or fund over 12 major field trials using mixed designs with RAP ranging from 20% up to 48%, incorporating Delta S to showcase the effectiveness of this material in the field. The section field trial that we're most proud of is the N7 section on the NCAT test track. That was first placed down in 2015. And the mix design we used was a 35% wrap mix design using Delta S as the rejuvenator and anti-strip, dosed at 5% to the recycled binder. It was a 1.5-inch riding course. Upon completion of our section, we achieved about 13 million easels, which is equivalent to between 15 and 20 years of highway traffic, depending on the highway that it's being run on. One thing I want to point out, and which is also the purpose of this webinar here, is to look at the NCAT team's experience with our product, but also to point out that the purpose of what we did here was to learn. That's the purpose of what NCAT is for. We had some repaves that needed to be done, 3 repaves to be specific, and with the results of the analytics in all 3 situations, unfortunately, the results were the failures were due to circumstances beyond our control, which the NCAT team will get into. I will say that we are confident, if not for the bottom-up cracking that occurred in the 2018 test cycle, which ultimately ended our participation in that cycle, we would have finished that test cycle and achieved upwards of 17 or 18 million easels with the completion of that. So in closing, I want to give everybody my contact information if you have any questions or comments after the webinar. And also just reiterate that we're proud of what we've accomplished here. We learned a lot, and we look forward to continuing with our Delta S technology. Thank you.
So as we've alluded to, the N7 test section has been down for 2 test cycles that were put down in 2015. So I'm going to go over the history of the section N7. As you pulling up those slides?
Actually, I was waiting for you to pull up slides, but then that's because I didn't remember that you told me you wanted me to do that. So that's on me. Sorry about that.
Okay.
There you go.
All right. So for the 2015 track cycle, N7 was milled and inlaid with 1.5 inches of high-aged binder content, RAP as well as RAS, mixed treated with 10% Delta S. This was placed in the summer of 2015. Cracking was first seen after 1.4 million easels as a result of a bond strength failure in the interface between the new surface and the old binder layer, the previous pavements that were already there. Section N7 was milled and repaved with the same mix, ensuring special attention was given to the tack coat in hopes of preventing another bond strength failure. When another bond strength failure occurred, forensics were performed to determine the source and prevent a reoccurrence. Testing determined that the short silo storage time, as well as the short 6-mile haul distance, had combined to prevent adequate reaction time between the Delta S and the aged and very stiff post-consumer RAS binder. Following this conclusion, the entire section, top to bottom, was milled to the top of the crushed aggregate base, and the asphalt layers were replaced in the spring of 2016. The base and binder courses were HYMA mixtures, built to the same design as those placed in N1, and the final 1.5-inch surface layer consisted of high wrap, 35%, and no RAS, treated with 5% Delta S. Performance of the resulting 35% wrap section was similar to the 20% wrap control section, which is section N1, through 10 million easels, or the end of that 2015 test track cycle. And advance that slide. And here we see the cracking data through the 2015 cycle for both the N1 control section, shown in orange, and then the N7 Delta section, Delta S section, shown in orange, or shown in purple, sorry.
All right, thanks, Jason. Before Delta S mix was placed on the track, we engaged in a pretty extensive laboratory testing process so that collaborative aggregates could have confidence that we were going to have good performance out on the track. And I'm going to talk about the 35% wrap mix, not the original mix that was 20% wrap and 5% post-consumer shingles. We're going to get back to that and talk about that more here in just a little bit. But before we put any mix on the track, the first question was, well, what dose rate do you use? And the dose rate was based on binder testing that was done. And essentially the target here was to end up with the same Delta TC for the 35% wrap extracted binder that we got for the 20% wrap extracted binder. And that was achieved, as you can see in this data. And then really one of the focus area for the testing on the track was iFit results. And as you can see in this graphic, we did achieve in the lab mix prior to placement on the track, the 35% wrap mix with Delta S was statistically equivalent to the 20% wrap mix without it. And then when we actually produced the mix that we placed on the track, the same thing was true with a 35% wrap with Delta S compared to the 20% wrap mix without. They were statistically similar.
So talking about track forensics for a second, one of the benefits of track research is the option for unique forensics, which sometimes includes full depth trenching. In this case, for Delta N7 and Delta S, an extensive coring operation showed that performance of the Delta S surface mix was confounded by extensive bottom-up cracking. Presumably, this was an artifact of the rapid rebuild procedure conducted during the spring of 2016. Maintenance patching required a portion of the middle of section N7, just a portion, to be removed as a result of this bottom-up cracking. The remaining portions of the section, those being the beginning and the end, remained in place through the end of the 2018 test cycle, supporting 17.5 million easels. If you advance that slide. So on the top left picture, you can see the middle portion of section N7, which was the milled portion. Down below that, if we step back a little bit in the section, you can see the beginning portion that was left in place, and then you can see the inlay that was laid above that. And again, that beginning and end portion remained in place to the end of the 2018 cycle. On the right is one of the cores we cut to verify the bottom-up cracking. The cracking pattern showed on the milled surface also confirms that the failure was due to bottom-up cracking, which was not directly related to the performance of the surface layer. So the middle portion of section N7 was milled and inlaid in May of 2020, and the unrepaired portion remained in place to the end of the cycle.
Well, thanks, Jason. So to kind of pull all this together and provide you with kind of an overview lab work that we did and the plant work that we did, and then also the performance that we measured. It's really easy to run these types of recycling agents because you can do it either by inline blending, just introducing it into the AC supply line at the plant. And at our plant, we have a static mixing chamber that's downstream from a multi-port injector, and you can just do that on the fly as you produce the mix. And then what we do, we have a tote sitting there, and we mark the beginning and the ending lines on the quantity that's in the tote, so we can double check our quantities when we do practice mix and pave mix. But we've also done this in implementation projects just by dosing tankers or dosing storage tanks. So you can run it either way. We've also done some work with off-track mix where we experimented with pre-dosing the wrap before it went into the wrap collar, but we didn't see a statistical advantage to doing it that way. So we just do the inline blending. As we said earlier, if you're going to add a product like this to a really stiff, age-hardened post-consumer RAS, like what we had when we first started this test section with collaborative aggregates, you need to be careful with that. And the reason why you need to be careful with it is you got to make sure you have an adequate reaction time for the post-consumer RAS. And if you don't have an adequate reaction time so that you have good penetration and good activation of that binder, then you may soften the virgin binder, not the reclaim to recycle binder, but the virgin binder. And that essentially is what we found happened in our forensics when we first built this test section. What we thought was a tack failure when we did bond strength testing, it really was a virgin binder softening that had occurred because we didn't have enough reaction time. Our plant is 10 minutes down the road, and we weren't running 2,000 tons a day. We do short production runs for the track. So it's not to say you can't use it with that. Just exercise caution if you do, and make sure you understand what you have. When it's done correctly and you do get good reaction, we have seen an improvement in our performance measures in the NCAT laboratory, and of course we also saw good performance on the track. Over 10 million equivalent single axle loadings, and that's approximately 6 million heavy axle passes if you would prefer to think of it just in terms of number of axle passes. But the performance in section N7 was comparable to the control over the 10 million equivalent single axle loadings on the 2015 track. Collaborative Aggregates, they believe in their product, and not only did they fund the construction of this test section as a full funding partner with all the state DOTs and with FHWA that are on the track, they funded traffic continuation in the 2018 research cycle. Unfortunately, as we've stated, and as Jason Nelson showed you in the forensics, the next 10 million easels was confounded by the bottom-up cracking that we experienced in that test section. And we think that happened because it was a rapid rebuild. We went in and did a full depth rebuild on that section when we had to take all the asphalt out, and we really believe that that's why that happened. But we took what we learned on the track, what we learned in the lab and at the plant, and then track performance, and then now we take those, use those positive takeaways to support implementation projects of various types. And so what we want to do is share some of that with you now here for the next few minutes in this webinar. And the first one that I want to mention is on US 169 up in a little community called Pease, Minnesota. This was in August of 2016. Remember, we built this test section after our laboratory testing and construction in 2015 on the track. So in 2016, as part of that 2015 research cycle, we were working with our research partner, which is Minnesota DOT through the Minnesota Road Research Project, and we were installing preservation test sections up in Minnesota that would match up with the test sections that we had built previously here at the National Center for Asphalt Technology. So part of that experiment, we've got emulsion treatments and plant mix treatments. So there's chip seals and crack sealing and microsurface, and there's different types of thin lays and then cape seals and combinations of those things. And one of those test sections is a 3/4 inch thick thin lay, and this is US 169 is a pretty heavily trafficked north-south route in kind of central Minnesota. So it has a traffic count that's very similar to our US 280 down here, where we have companion pavement preservation test sections. So there's a lot of traffic on this roadway, but more importantly, there's really aggressive thermal cracks, and you see that in this picture that I'm showing you in this slide. All the test sections that we built in Pease, Minnesota, have some type of reflected thermal cracks in them. That is certainly the case with the Delta S test section, which was 20% binder replacement with 11% fine fractionated wrap and 3% shingles. So this mix did have shingles in it, and we dosed it, I think, at 5%, like we had done at the test track. And we didn't have an inline. We did, I think, have an inline blender where we added this material in at the plant. It was set up like that so that they could add things like liquid anti-strips, that type of thing. And construction was good, and performance has been good so far in an area of the country where the air temperature can easily be minus 40, minus 45 degrees. So this is a very aggressive thermal crack environment, and we had good construction experience, and we've also had good performance experience in Pease, Minnesota. And we also want to give a nod to our friends at Minroad for making the northern half of our partnership possible. Those guys are great to work with. The next field implementation project that I wanted to mention to you was in December of 2017. Obviously, if it's December, we're not paving now up in Minnesota because everybody's hunkered down in their basements in Minnesota in December. So in this project, this was in Eufaula, Alabama, where you see everybody still standing around wearing short sleeve t-shirts and golf shirts on the shoulder of the roadway. It's also a pretty heavily trafficked roadway. It's US 231 there in Eufaula, so it's a divided 4-lane. And on this project, the northbound truck lane, about 3/4 of a mile of the northbound truck lane, we used to put down some treatment mix that could be directly compared to the surrounding control mix. Now we did get involved in this project early enough that we took our distress van down to the location where the paving was going to be done. So we were able to make sure that statistically we picked a good treatment section and a good control section so that the outcome of the study would not be confounded. There also was a buildup change in the middle of this project. If anybody is online here with Alabama DOT, you might be familiar with that. So we made sure that the treatment versus control on this project, it was an apples to apples type of a comparison. Here, the contractor reported that they were very pleased with the workability of the mix and the compactability of the mix. It was a 1.5-inch mill and inlay. So this is a roadway that had a lot of cracking in it, and it was not possible to do a rehab and go deep enough to do a long-term repair. So if I'm remembering it correctly, it was just 1.5 inch mill and inlay. It was 20% wrap, where that mix that I showed you up in Pease, that was a 475 mix that I think was 6.1% asphalt. And there in Eufaula, that mix is a 3/8 mix. It had 5.1% total asphalt content. And as I said, it was the northbound truck lane. And performance has been good on this test section so far. And Jason Nelson is going to give you an update here when I'm done with my part of the presentation. So the third implementation project that I wanted to talk about is State Route 42 in Atlanta, Georgia. This was done on April the 18th of 2019. This is otherwise known as McDonough Boulevard Southeast. This was a night paving job. And we took the section of this roadway that I have highlighted in yellow. We ran tonnage that was treated with Delta S, and we did that kind of in conjunction with the whole rest of the roadway. Now, we did not have the opportunity to do testing beforehand and make sure we had a good treatment and control comparison. Like we had no way of knowing is the pretreatment condition of this roadway going to be similar to the surrounding road. We did note when we got out there, again, it was a night paving job, that there were some water issues. There was actually a leaky water line that was in the vicinity of where this mix was placed. But we did have the opportunity to do some bulk plant sampling, so we could take that back to NCAT and do Hamburg loaded wheel testing, and then ideal CT crack performance testing or crack indicator testing. And we the mix design here, I think, was 35% wrap, the standard GDOT mix design. And we actually redesigned that through a balanced mix design process using Delta S. And so the treatment mix was 50% wrap. The only problem we had with this job, other than the fact that it was a night paving job, which kind of carries its own little nuances, the 50% wrap mix design had really good balanced mix design test properties in the laboratory. But because of the wrap that we were working with, I think it had a little tendency to segregate. We did use a material transfer device when we were paving this, but we still saw a little bit of segregation in the middle of the mat. I'm not aware that there's been any performance issues associated with that, and we did see an improvement in the ideal CT numbers as a result of the addition of Delta S. I think we got about 20 points in ideal CT testing. And we actually were able to run this. We ran the 35% wrap control, and we ran up to 50% wrap with and without Delta S. And so we were able to see in the laboratory the benefit of Delta S with that high wrap mix with and without the product. So that was pretty interesting. And as I said, I think we got about 20 points out of that.
And so I'll give a brief update on the Eufaula job. Buzz has talked about a couple of jobs. Remember, this is the one that was placed in December of 2017. So AlDOT placed a section of Delta S modified mix as part of a 7.6 mile resurfacing near Eufaula, Alabama. All 4 lanes were part of the project, but only the northbound truck lane was utilized with the Delta S mix. A control section and a Delta S mix section of about 3,700 feet were placed. And NCAT has monitored the project for surface performance since it was placed. Maybe you'll advance that slide. So we recently collected the 3.5-year data with our automated distress van. The control section, which again was identical in length, and was chosen based on a statistical comparison of pre-treatment data of cracking, rutting, and ride. The 3D van is not detecting any cracking at this time. However, ride, rutting, and macro texture show no statistical difference to the control section. But looking at some numbers, you can see how they're both tracking along well together. So ride for both the control and Delta S sections are currently near 50 inches per mile. Sorry, we're one slide up. There we go. And just advance on to the next one for rutting. Okay. And as with ride, rutting for both the control and Delta S sections have less than 1/4 of an inch. And again, they show no statistical difference in performance. And so questions have been coming in the chat, and I'm just going to read them in the order they came in. Some of these we may have answered, but later in the presentation, we'll go ahead and read them again. Were any changes made to the tack coat in the 3 trials?
I guess I'll fill that one. I think we did increase the tack when we did that first repave. And just to be clear, we built that test section, then and that was with 20% wrap and 5% post-consumer shingles with Delta S. We rebuilt it with that same mix with a little higher tack rate, and it failed again. So we went back and did a big forensic experiment, and we went back to our standard tack rate when we did that second and final rebuild. And in that final rebuild, it was 35% wrap with no post-consumer shingles.
Yeah, so we increased it for the second pave, and then we maintained the same tack coat for the third pave. Next question, how can we measure, evaluate the bond strength of HMA?
There's several different ways to do it. And I think recently there was an NCHRP project on that. And essentially you can pull it or you can shear it. The simplest test is just to use a Marshall press type machine with a box shear in it and just slip the planes past each other and convert the load to a stress or a strength value, peak load to strength, shear strength. But you can also apply a confining stress to that, and then you can manipulate the load rate. And there's lots of things that you can do to try to make that as similar as possible to actual vehicle loading on a pavement structure. But what we have found at NCAT is that mixes all rank the same. Everything that we've looked at, whether you use confining stress with a manipulated load or just a simple Marshall press in an unconfined box shear. So that's the process that we use here at NCAT and at the NCAT pavement test track.
And the video of the presentation will be made available. Travis, do you want to comment on the details on when and where that was shared?
That'll probably be shared on the NCAT website once we get it post-processed.
Okay. The next question, isn't a delta TC of -10 considered to be too low?
That is a low delta TC, and I'm not a binder expert, but the goal was to match the control mix as closely as possible, and you know that was in the range of the control mix that was 20% wrap. And the reason for that is because of the age condition of the wrap that was in both mixes, the control and the treatment mix. So we weren't adjusting the dose rate to try to fix delta TC. We were trying to match delta TC.
And a little bit of backstory on that control mix. It was part of a larger group study called the cracking group experiment, which was 7 different test sections. And they were supposed to span a wide variety of crack susceptible mixes. So that's one reason that delta C was where it was, or that delta TC was where it was. Jay, this may be one towards you. What's your chemical and the physical properties of delta S?
Thanks, Jason. I'm not really sure what is meant by the chemical properties, but physical properties, it's liquid at room temperature, consistency, viscosity a little lower than, say, a motor oil. Doesn't need to be, heated. It's, again, liquid at room temperature. I think that's about the gist of it. Non-hazardous, non-regulated, as I mentioned earlier, adhering to the 12 principles of green chemistry.
And this was direct to me, so this won't be in your chat, but did the team consider increasing the dosing to facilitate the RAS use? What besides dwell time in the silo storage could assist in the delta S use with RAS, or should producers and agencies focus on its use with RAP, not RAS? Did you get all that, Buzz?
I can handle that. We were only able to figure that process out by essentially doing a whole series of different aging of mixes in the laboratory, and then doing mixed property testing on the different stages of aging. I might not have done a good job of explaining it, but what happens is when you don't get that reaction because that here in the Gulf Southeast we have probably as high of a stiff of a post-consumer shingle binder as anywhere in the country, and that stuff is just so stiff that when you don't have an adequate reaction at an elevated temperature, no storage time through the silo and through the hull, then you run the risk of having a softening effect on the virgin binder, and that's what happened. Now we went in and I don't have all that data here in front of me, but we really dissected that situation. Dr. Nam Tran was the PI on that, and he did a great job of figuring out, what was the cause, and we made the decision in conjunction with Collaborative Aggregates. Let's just go to a 35% wrap mix here so that we can compare it directly to the 20% wrap mix without the confounding effect of the post-consumer shingle binder in this mix.
So again, it was an extreme case with that RAS binder. What is the recommended reaction time if adding at the mix plant?
That might be a question for Jay. For us, when we ran 35% wrap, we didn't have to hold that material in the silo. And just to kind of explain a little bit better, when we built a test section, we really only need a couple of good truckloads per lift, when we install that test section. So, if you've got a multi-100-ton silo, we're using a very small part of that silo, and it is not like, that part of what we do is dissimilar from conventional paving when you got, when you're running 2,000 tons a day. That's the reason why that became an issue for us in this case. When we ran the 35% wrap mix, I don't recall that being an issue with us at all. Do y'all have any kind of recommendations that you could offer on that issue, Jay, for production paving?
No, not really, Buzz. There's been no siloing of any of our material for any projects we've done outside of NCAT. So I would say there really is no silo time. I will also say that we haven't really used a lot of RAS, since that trial, and it seems, at least from my perception through industry, the RAS use has decreased. So we, it's primarily been wrap. Again, upwards of 48%, I think was our highest percent of wrap, and we didn't silo that at all, and it's performing great.
Well, and I would add to that, Jay, that on the implementation projects that I've talked about, the Georgia job and the Alabama job, those were production projects. So there was no part of that work that was modified in any way, because it's a money job and the contractors are in business to get tons down and compacted successfully, because they're going to be paid based on tons. Neither one of those projects, as you said, had shingles in them, and there were no special considerations to any kind of storage. It was just produce and go in the typical operation. When we did the thin-lay paving up in Pease, Minnesota, we had no special storage that we placed on the plant, where we were producing the mix, but we did have, my memory is it was about an hour haul distance between where we were producing mix in Becker, Minnesota, and where we were paving mix in Pease, Minnesota. I know it was at least 50 minutes. I think it's probably closer to an hour. That mix did have shingle binder in it. It was, as I said, it was 11% fine fractionated wrap and 3% shingles, and we didn't have any issues with that process. Now, but we had 5% shingles here in Alabama, and I'm sure the shingle binder was much stiffer than what we were working with up in Minnesota.
Okay, and next question, if we're done. How did you assess through testing that the RAS was not blending? This would be for the first two paves on the test track for N7.
I think we already answered that one, and it had to do with we mixed sample up in the lab that had RAP and RAS and Delta S in it, and then we had different curing times. So and again, Dr. Tran was the PI on that, but he wanted to look at what is happening over time with this mix, and I think he developed a good understanding of it based on that. So he took, if I recall it correctly, Jason, correct me if I'm wrong, but we took pans and had loose mix in a pan, and we left it in the oven for different periods of time before we compacted the specimens, and through that process and sample characterization testing of compacted pills, we were able to understand what was going on.
Okay. And what kind of plant was used to produce the Delta S rejuvenator? What is the implication on the performance of using this Delta S rejuvenator in high moisture condition, tropic regions, and the use in porous asphalt? I'm assuming the type of plant, you mean what asphalt plant was, Daniel? What asphalt plant was used, or do you mean where was the Delta S itself was produced? May have to come back to that.
I would just say if he is talking about what, the plant extracted oil, that is proprietary. So unfortunately, I'm not at liberty to speak to that. And as far as tropical countries, we haven't had an opportunity to really test Delta S in that environment. I think Alabama is about as tropical as we've gotten. But we're open to opportunities and looking at new areas. And if you want to reach out to me directly, I'd be happy to talk to you further. And
in terms of the plants that we produced mix with, at the track we have an Aztec double barrel plant. I believe that the Georgia project was also with an Aztec double barrel. The Eufaula project was with a single drum counterflow, and the Minnesota project was also with a single drum counterflow, if I'm remembering all those correctly. So we've done a lot of mix with single drums and with double drums. And as has been mentioned, it's pretty, we get quite a bit of rain in the Gulf Southeast and quite a bit of humidity, especially on night paving jobs.
Okay, and does rejuvenation of RAP and RAS continue at pavement temperature only at hot mix temp?
I think that depends on the stiffness of the reclaimed and recycled binder. And again, if you're looking at the PG grade of our shingle binder here in this part of the country at our latitude and in the Gulf Southeast, that binder is like a PG 170. So I mean, it's incredibly stiff material, and that's the reason why it takes some extra time. We've not had any concerns about the wrap binder and having an adequate reaction time with any of the wrap binder that we've done. But the shingle binder for us is it is kind of an ongoing challenge for people who are using that material. And you can run good mix with it. We've had preservation mixes down here that are still in service out on US 280, like the mix up in Pease, Minnesota. It's kind of the cousin to that mix, and they both have 3% shingles in them, and they're both doing it extremely well. They're 3% shingles and 11% fine fractionated wrap. So I don't want to give anybody the vibe that you can't, that you don't need to do shingle mixes. It's really all about balanced mix design and good cracking performance and good rutting performance. And virgin binder and reclaimed and recycled binder and recycling agents are all part of the equation that gives you good cracking performance and good rutting performance. The reason why I those of y'all who know me know this, I'm really excited about balanced mix design, whether I'm wearing an agency hat or whether I'm wearing a contractor hat, because it's going to get the agencies good performance, and it's going to give contractors room to innovate. And I think that recycling agents are in that innovation space at the plant.
Okay, just a few more. How was the performance of Delta S against aging? And there's a rest of his question, but I think we've covered those with porous asphalt concrete and SMAs.
I think in our laboratory testing, and again, NAM is a PI, but my understanding is that when we do mixed characterization and binder characterization, we do plant aging and then we do critical aging, and I think the key to recycling agents is that they need to have an enhancing quality to the binder that lasts out into the future at that 4 to 5 year mark that we've determined to be really important regarding whether a mix is going to crack or not going to crack. And I believe that our laboratory testing has been favorable with that critical aging. But it's really important with recycling agents. And Jay alluded to this in his introductory remarks. It's not just about softening mix at the time of production in early life. It's about having true rejuvenation out there in the performance life of the mix. And so that's the reason why laboratory evaluation using critical aging is an important thing to look at to make sure you're going to get that.
And next question asks about other field sections. understanding there was maybe some problems with the Delta S project in Nebraska.
Yep, I can grab that. All the field projects have performed very well. We did have an issue with Nebraska on that specific trial. What happened was it was grossly overdosed. And obviously with an overdose, you're gonna end up with a mix design that's too soft. So that was immediately pulled back up, repaved with the correct amount of Delta S, and has performed fine ever since.
Okay. The next question is, the place where the rejuvenator should be added in the asphalt plant will depend on the rejuvenator source. I'm assuming that, does that mean rejuvenator type, Camilla?
Yes.
Bob, you want to handle?
I'm sorry, I didn't quite understand that question, I think.
Does where you need to add the rejuvenator in the asphalt plant, does that vary depending on what type of rejuvenator you're adding?
I think that it potentially could. You know, if you look at countries where they're running really high RAP percentages, they're using they've got separate mixing drums and they've got curing silos, and they're kind of, they've invested in the iron to optimize the reaction process. I think some of the materials that you might want to consider for recycling agents, maybe you need that depending on how much reclaimed and recycled material you're going to run. And I think probably some of the technologies you may want to introduce right before the plant, like we have done with Delta S. And I think some of them you can just add in the AC supply line, like we've done with Delta S, with the percentages of reclaimed and recycled binder that we've run. I think it depends on your technology, and you certainly need to do evaluations to figure out how you need to handle that, and how you can really, with balanced mix design, it's all about producing mix for paving that is going to be crack resistant and rut resistant. And our challenge in doing mix designs is to put combinations of materials together that are going to hit that target, and then we submit that for design approval to agencies, and then the agencies need to make sure that critically aged sustained benefit is going to be there like they need it to be there. So I don't think there's a one-size-fits-all answer to that question. I think it's specific to the virgin materials and the recycled materials and the recycling agent that you're using.
I will say we had an opportunity with NCAT a number of years ago where they produced 2 plant mix batches, one where we inline Delta S, and then the other one where we collar sprayed Delta S directly onto the recycled material as it came down the belt. It was just a very quick test, and then samples were taken. The NCAT lab ran compaction and air voids, and they were identical. I would say primarily most of the time Delta S is inline blended. I think it's just easier for folks to just plug and dose that way.
Okay. Next question is how to find the long-term efficiency of the rejuvenator in the laboratory, and we've sort of talked about that with the binder testing that's being conducted.
Well, and I'll jump in and say this: I'm a big advocate of mixed testing, because you can kind of go down rabbit holes with all the mixed constituent testing that can be done. And I'm thinking like an agency guy, like when I was with Alabama DOT, I'm a big advocate of let's look at the mix, and then let's let innovation take care of the things that we put in the mix. And that's why critical aging is important. You know, you want to age loose mix in the laboratory to make it chemically look like it's 5 years old, and then put that in a gyratory compactor, compact those specimens to 7%, plus or minus what the specification requires for the test that you're running. Then do the evaluation, and if you get good performance with that type of what we call critical aging, then you can expect to see good performance on the roadway. Now, when you're doing BMD QC testing, which we do here at the track, anytime we do pave cycle, rebuild cycles like we are this summer, or anytime we do maintenance mix, like some of the maintenance mix that Jason described in N7 that was done, we do QC type testing, rapid testing without any aging. But for mix design approval, the agencies need to have confidence that the mix is going to perform well in the future, and we have a good methodology for that.
And the next one was a direct message to me, so you want me to see this one as well, but it's how do you recommend to find the optimum dosage for the Delta S?
Who was that for? I'm sorry.
I guess either you or Buzz can handle that one. What's the how do you find the optimum dosage?
I think you can either look at binder chemistry like Nam did on the track test section, and if you've got something that you're trying to compare it to, do something like match Delta TC or match the PG grade or match viscosities of all the extracted binders. But I think you could also do it with mixed BMD testing. So I think you could. There are several different ways you can kind of iterate, vary the dose rate, and evaluate the binder properties, or evaluate the mix properties, or both, to achieve the outcome that you desire.
Yeah, I agree with Buzz as well, but I will say most folks we find they're not doing that. So as a general recommendation, 4 to 5% to the recycled binder is where we recommend you start.
Okay, and the next one is what is the maximum life of HMA with Delta S? Are we able to reach 15 to 20 years equivalent in the PAV? I'm not sure we've determined that yet.
Yeah, I think if we knew the answer to that question, we wouldn't have to build test tracks and do full scale testing. So we hope that we've gone a long way towards evaluating BMD tests and fatigue testing and modeling, so that we can answer questions like that. But I don't think we're there yet.
Yeah, and that's why we partnered with NCAT. We're the new kids on the block. We're scientists. We're science and data driven, and this was the quickest way to get the best field data, longevity of field data as fast as possible. And that's again why we partnered with NCAT.
And we've got about 3 minutes left, and looks like the last two questions I've got in the chat are dosing questions. So what's the acceptable tolerance? And they're referencing that Nebraska job.
Yeah, so again, 4 to 5% to the recycled content is our recommended dose to start. And in regards to that Nebraska, unfortunately, there's some legal things going on at this point, so I can't really speak to that Nebraska job much further than what I've already said.
And have you done any testing with Delta S as far as natural asphalts, as like bituminous sands or the Trinidad Lake asphalt?
I can't recall, but I'd have to say at this point, no.
We interestingly, we built a test section on the 2009 track that was built with Trinidad Lake asphalt, but at that time, that was back kind of before the era of recycling agents. So we've not, that I recall, we've not done any research in that area either.
And one more question. We got about 2 minutes left. Which is the best method to age the mixture, compacted mixture or loose?
I'm a big advocate of loose mixture, and the reason why I say that is because you have to use a lot more heat and a lot more time with compacted specimens. So with loose specimens, whether you're doing contractors doing mix designs, or whether you're an agency approving mix designs, the time frame for critical aging with loose mix in a pan is very realistic. For example, if you mix up material, put it in a pan, you can age it for 2 to 4 hours, depending on who you talk to, at 275, and chemically it's going to look a lot like it. Rheologically, it's going to look a lot like it looks going through the plant. If you add 8 hours to that, then you have made it look a lot like it's going to look at our latitude here in Alabama after about 5 years of aging, and we have verified that on the track. So I'm a big advocate of let's don't burn time. Let's just get the right number as efficiently as we can. And for me, that's going to be loose mix.
And
And
Daniel, if you want to email me directly, I'll look into the bituminous sand and if there was anything else we have done to get that information to you.
I wouldn't see any, huge red flags in doing that, because you're already blending it with wrap binder.
Right.
So as long as you can get the penetration in there and get the two properly mixed, I think it would be possible.
Yeah, I think we did do something in Texas, but I need to confirm. So I see you responded, Daniel. So go ahead and email me, and again, I'll dig into it and get you the information.
Okay. Well, it is 3:30 on the dot.
Well, this has been a lot of fun, and we appreciate everybody taking the time this afternoon to visit with us for an hour. And I think Travis is working on more webinars for the future. So stay connected to the National Center for Asphalt Technology, and we'll be rolling out more useful information for you in the future. We appreciate everybody, and we hope y'all all have a blessed day.
Thank you, everybody.
Thanks a lot.